Hey guys, I'm going to walk you through this volumes of revolutions problem. The question says, rotate the region bounded by x equals y minus 2 squared, x equals 0, and y equals 0 about the x-axis. So that means x equals y minus 2 squared, x equals 0, and y equals 0. Those are our boundaries. And then rotating it about the y-axis means that is where we're flipping this shape right here. And that's where we're finding the volume of. All right? So to solve this, we need our volume equation. This is volume equals 2 pi times the integral of x times f of x dx integrated from b to a. All right? And because we're not dealing in terms of x's here, we're dealing in terms of y's because we have our x equals blah, blah, blah. Over here, x equals y minus 2 squared. We're going to set these to x's, all right? So we have x equals, we can turn this x into y, and we can turn this fx into f of y. All right, the same concept, same format. All right, so we're inputting these values down here now to simplify. We have v equals 2 pi, evaluated at the limits, y times y squared, y times y minus 2 squared dy. All right, and we get our limits from looking up here. First we see where our lower limit is, and that's at y equals 0, because that's where the bottom of the function is. And then up here, our upper limit is at 2, because over here, if we set y equals y minus 2 squared equal to 0, we see that our y is 2 when y equals 0. All right, or when y equals 0, when x equals 0, our y is 2, because we're using the inverses of our functions basically, or we're flipping them. So we simplify that down again. We have the volume equals 2 pi integrated from 0 to 2 of y times y squared minus 4y plus 4 dy. And this equation down here is just that, this part up here, y minus 2 squared, that's just this expanded. So we go down again, the volume equals 2 pi evaluated from 0 to 2 of y to the third minus 4y squared plus 4y dy. Again, this time we're distributing the y to the rest of our equation. All right, and then the integral of this, ignoring all this over here, is 1/4 y to the fourth minus 4 over 3y cubed plus 2y squared evaluated from 0 to 2. So that means if we took the derivative of this function, it would give us this right here, because we're taking the integral of that. And then we multiply that by the 2 pi, which is still on the outside. And then we, to find this integral evaluated from 0 to 2, first we plug in our 2 to all of our y's, and then in this function, then we do the function again, except this time we plug in zeros, and we minus the 0 function from the 2 function. So we have 1/4 times 2 to the fourth minus 4/3 times 2 to the third plus 2 times 2 to the second. All right. So this is our upper limit, upper area. Then minus 1/4 0 to the fourth, because it's our lower limit, minus 4/3 0 to the third plus 2 0 to the second. All right. So this all just equates to 0. So we have our original function, our upper limit function minus our lower limit function, which is 0. And then we simplify this down, and we get -12. We get 12 over 3, which is 4, minus 32 over 3 plus 24 over 3, which is 8. So over here, I just simplified all this down, skipped a few steps, a few of the algebraic steps. And then over here, and then this is all still being multiplied by 2 pi. And then we simplify that. You get, because this all equates to 4 over 3, we get 8 pi over 3, and that is the volume of this rotated around the x-axis.